All right, welcome back. We got 5.2 notes here. Again, like I said, continuing working with this normal distribution and tables. Now we're going to use it to find probabilities, but the process is the same. We just apply it to finding a probability as opposed to just that area under the curve. That percentage, right, is what we're always finding. Well, now that just becomes our probability. And now instead of always dealing with the standard normal curve, we're going to be dealing with normal curves, so we have to find our z-score from that, which then we use the z-score just how we've been doing in 5.1. So as you look at the problem, it looks something like this, right? We have our sketch there done already. So random variable is normally distributed. You can find the probability that x will fall in a given interval by calculating the area under the curve. Right? The area in the curve is what we did in 5.1. We had z-scores that we took to our table to find that area. Well, now we're given information. And remember, we had found previously z-scores by z equals our value minus our mean. And so previously we had found our z-scores by our value minus the mean over the standard deviation, which in this case is our x minus our mu or our mean over our standard deviation. So our z-score for this one is going to be z equals 600 minus 500 over 100. So z equals 100 over 100. So that is a z-score of 1. And so we can take that z-score of 1 to our table. All right, so our z-score of 1, so 1.00, 0.8413. And so the probability of this is 0.8413 or 84.13%. And that would be the probability that any value would fall within this shaded area there. And we're not going to worry about the graphing calculator. And so you can see the work that we just did, how we found the z-score of 1 was the corresponding z-score to the x value of 600. So as we took our normal curve and translated into our standard normal curve, the shaded area stayed the same. All that changed was our mean became 0 because we standardized it, and then our x value ended up being 1 standard deviation away, so 600 became 1, which became our z-score, which then we could take to our table. But that value, that 84.3%, is the same. 84.13% is the same in the normal curve as it is in the standard normal curve. So let's look at a problem here. A national study found that college students with jobs worked an average of 22 hours per week. Standard deviation is 9 hours. A college student with a job is selected at random. So we're going to find the probability that a student works for less than 4 hours per week. Assume the lengths of the time college students work are normally distributed and are represented by the variable x. We're going to draw a normal curve, just like we were doing in 5.1, with both the x scale and z scale. I'm not super worried about that. I just want it labeled. And ideally, I just do the x because it's going to get found in the z scale once we find our z-score. So we have our average, which is our mean, so that's 22. They tell us we have a standard deviation of 9. Our mu is 22, as we said. And then our value this time is 4. So there's 4. And then pay attention, we're looking for less than 4, so that's to the left. So we're finding that area there. So then we need to identify our z-score. So z equals our value, which is 4, minus our mean, which is 22, over our standard deviation. So 4 minus 22. So negative 18 over 9, which is negative 2. So we have a z-score of negative 2. So then we can take that to the table. So there's negative 2, and it was 0, so 0.0228, or 2.28%. Okay, so the probability of finding a randomly selected college student that works less than 4 hours per week is 2.28%. All right, next problem. So a survey indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes. Okay, so identifying important things there. All right, so there's our average, and then our standard deviation. Find the lengths of time spent in the store are normally distributed and represented by the X variable. Okay, so they tell us they're normally distributed, which is important. That allows us to draw our normal curve. All right, so our specific problem. So we want to find the probability that the shopper will be in the store between, okay, so we know we're going to do a little bit of work, between 22 and 52 minutes. So our means there in the middle, and we're between 22 and 52. So we're really looking for that area in between. But remember, in order to do that, we're going to find the 52 to the left, and then we're going to find the 22, and we're going to subtract those two values. Now, we can't take 52 and 22. Those aren't z-scores. Those are x values. So we got to find the z-score for both first. So z1 is going to equal 52 minus 43 over 12. And then z2 is going to equal 22 minus 43 over 12. And so for z1, we get 0.75 for a z-score. And for z2, we get negative 1.75 for a z-score. So we take those two z-scores and we go to our table, find our percents, and then we'll subtract those two. All right, so we started with 0.75. So we got 0.7734. And then we had negative 1.75. So 0.041. So we'll take both those values back, subtract them, and that'll give us the percent in between what we need. So we had 0.7734 and 0.0401. And we get a final answer, 0.7333, or 73.33% probability that a shopper will be in the store between 22 and 52 minutes. All right, so we're going to skip 3. Don't necessarily like how that problem's worded, and trying to reword it can be a little confusing. So I'm just going to skip that now, and we'll keep focusing on the z-score idea. So we look at number 4 here. We want to find the probability that the shopper will be in the store more than 37 minutes. So we're going to draw our normal curve and work through that. Okay, so again, we're at 43. We have 37, and we want more than, so that's going to be the right side. So it's a quick reminder, hey, we're going to have to go 100 minus or 1 minus once we find that. But I need to find my z-score first. So z equals 37 minus 43 divided by 12. So we get a z-score of negative 0.5. So we'll take that to the table. So there's our negative 0.5, and it's just that. So we have 0.3085. 0.3085. So for this amount, we go 100 minus 30.85. And we get 69.15%. And then 5's similar question, we'll skip that as well. Okay, so again, using normal distribution to find probabilities, well, it's a percentage, which we know, or even the decimal form is a representation of probability. And so we can use our x value to find our z-score given a mean and standard deviation. That gives us a z-score, which then we can take to our table and get our percentage, which then equates to our probability of finding a shopper that will be in the store more than 37 minutes, which would be 69.15% of the time. And then, or a probability that shopper will be in the store between 22 and 52 minutes. And that was 73.33% probability. All right. And so with that, so we go down here, you have your own problems that we're going to work through. So try 6, 7, and 8 on your own.